To go over the example here, we've got, you throw a frisbee to your friend across the jug yard. If the jug yard is about 50 meters long, right away that's your displacement or distance. The air resistance negatively accelerates the frisbee at a rate of, and here you could have 2 or 3 depending on which quiz you had, 2 or 3 meters per second squared, and you want it to land in your friend's hand with a velocity of, I have 10 meters per second or some other value you could have had, 12 or 10. With what velocity should you throw it? So the length of the jug yard, what variable does that represent? What variable, James? X. That's the length of the jug yard. You're told that the air or the wind negatively accelerates it. It's called resistance. Whenever something is resisting you, it acts opposite your motion. So if you're moving with positive velocity, to act opposite the motion would be what kind of acceleration? Deceleration, good. Or negative acceleration, which you'd happen to say. So that's going to be negative, and I have, it doesn't matter what you have in front of you, but I have 2 on my quiz here. Okay, some of you had 3 for that part. Same thing. Okay?
In general, on the problems.
No. Let's keep going. No problem set questions. We'll go back. Next, we're going to then look at, it says it wants to land in your friend's hand with a velocity of 10 meters per second. So, the beginning of this situation, you're throwing a frisbee, and it's ending in your friend's hand. So that ending point, when it ends in your friend's hand with a velocity of 10, that's final velocity, because that's the final part of the problem. Okay, that's how you know it's the final velocity. So it ends in your friend's hand with a velocity of 10 meters per second. That's at the end of the scenario. And then they say, with what velocity should you throw it with? When you throw it, that's like the beginning of the problem. So we call that the initial velocity. So we're trying to find the initial velocity. So again, we're searching for this quantity. Most of you got the next part right with your equation. The only one that doesn't have time is the third equation. So you have to use that one here. Now, some of you at this point have been plugging in numbers, and that's completely fine. You can do that. But I'm going to solve generically. I'm just going to take this quantity and move it over. It's currently being added. Why can I move this whole quantity over at once? How come I'm allowed to do that all at one time? Tristan?
Because if you divide both sides by that.
No, not that. We're not dividing. James?
Well, because since it's just variables, and like it's all one term.
Yeah, this is all one term. That's exactly right. This is one term. In math, you need to know your words. Terms are separated by plus or minus signs. Whenever this is lumped as one term together, since we're not looking for any of these variables here, just move the whole thing over. So what can you think of this as? What did I talk about yesterday and the day before? What can you think of 2ax as?
It's like a number.
Just a number. So think of it as plus 5. How would you get rid of a plus 5, everybody? Minus 5. Now do you see why you're not dividing? So you need to subtract the quantity 2ax, the entire thing from both sides. So subtract 2ax, subtract 2ax. You get vf squared minus 2ax equals vi squared. Yeah.
When I'm subtracting to that side, does the initial term that was already there before always go like before?
Yeah, so read, how would you read this? You would read it as vf squared. I'll read it when I'm pointing also. I read it as vf squared minus 2ax. So you need to write it that way as well.
Okay, because sometimes in homework I didn't know where to put it all the way at the end, so it's
Negative 2ax plus
Yes, that's the other way you could have written it. That's correct.
Negative 2, like 2ax minus vf.
No, that's not correct. That's not correct. Vf squared has a positive sign in front of it, always here. Okay? If you move this over and you put it in the front, you could have written these backwards and written it as negative 2ax plus vf squared. Okay? The solution you get for this problem here is your generic solution. If you can get to this point on the test, you're almost like 3/4 of the way done with the problem. You listed your givens, you listed your desired variable, you listed your initial equation, you solved generically. The last step is just to plug in now. So if you do all this, and it's worth 5 points, that's 4 to 5 points right there. If you mess up the last step plugging in, that's only 1 point to me, because you've done all this work. But if you only list the givens, and you go right to plugging in and you make some mistakes, So for example, you list this and you plug in right away. This is only step 3. So you're only like 3/5 of the way. If you do the work generically, you're going to get more credit that way. If you get it right, either way it's good. Is that clear? But if you get to this point where you're at the equation up here, where you have the equation, then you plug in numbers, and from there you go wrong a few ways, I'm going to take off more than 1 point because you're clearly not solving correctly. But if you could show me that you could solve generically first, then you get that credit for solving.
Now, even though we're looking for VI, it's okay to leave the generic solution in terms of squared.
Well, at the end we're going to take the square root.
Okay,
Yeah.
but like,
So if you want to write it this way, James, you can write it like this. Oops. You can write it all into the square root for now.
does that matter to you?
No, it doesn't matter whether it's at the end or the beginning. But if you want to do what James is saying and take the square root now to get VI by itself and leave it with variables and then plug in, this technically, James, is the real generic solution. You're right. The step beforehand, it's a generic solution, but the squared solution of that. Okay?
Which would be easier? So
Honestly, it's up to you. Whatever you think is easier in your mind. If you want to calculate this number first, calculate this number first, and then take the square root. Or go ahead and just put it all into the square root at once. But the key is to remember this plus or minus. Why is there a plus or minus here? We talked about this quickly in class. Why is there a plus or minus in the front?
does it depend which way it's going, east or west?
Sure, but mathematically, why is it a plus or minus? Answer that. It does matter east or west. That will help us at the end. But mathematically speaking, why do I put a plus or minus there?
Because the answer would be an absolute value.
Close. When you square something, it's like the absolute value, because when you square what? Take the number -6 and square it. What do you get? Positive 36, right? So when you take a square root, it could have come from a negative number or a positive number, either one of them. So you have to put that there. Here's the reason. I take this pen and I drop it, and I catch it here. On the way down, what is the velocity called? Negative. So if I was solving for a problem and I was solving for VF, and say I got VF squared here, and I take the square root, and I get an answer, and the object we're traveling down, which answer do I take? I take the negative answer because it's moving down. In this problem, take a look. We've got a final velocity of 10. Julian, if I want to throw it to you and land it to you at 10 meters per second as a velocity, I need to throw it a little bit faster than 10 because I know it's going to slow down along the way.
Unless the
That-
wind goes
Sure. No, but nothing will accelerate along the way unless the wind is helping you. But if the wind is wind resistance, it's going to slow down along the way. If I were to throw anything and the wind acts against me, it's slowing it down. So my answer for VI has got to be bigger than 10. Again, for Julian to catch it with a velocity of 10, I've got to throw it faster than that because it's slowing down along the way. So right away, I'm going to get 2 answers here. But the negative answer is clearly not right because I'm not throwing with a negative velocity and ending up with a positive velocity. It doesn't make any sense. Okay, unless the acceleration we're overcoming in the other direction completely. But look at the context of the problem. I'm throwing it to somebody. I want it to land with 10, but it's slowing down, so I've got to throw it with something bigger than 10. So whatever answer you get here, you're going to choose the positive root. What was the number that it turned out to be for this part? And there were 2 answers depending on which problem you had. 17.3, what was the other one? What was the other one? Did anyone get the other one? So let's just use this one for the sake of this question.
What did you mean, like in radical form?
Not in radical form, but I gave 2 examples of the quiz where the acceleration and VF were different. I gave another version of the quiz with -3 as acceleration, and I think it was like 12 as VF. So you'll get a different number or whatever it was. But this might not even be the number for this problem. This might have been the number for the other one. But the idea is that you really get a plus or minus in front. You really get a plus or minus, but you can't have a negative velocity and then end up with a positive velocity if it were slowing down. That doesn't make any sense. Okay? It's got to be something like 17, and then it slows down and ends at 10, or whatever the number turned out to be.
So, like in the problem sets, there was one where it's like, the guy's taking a bus and he's going west with the and it was looking. It was, I forgot what he was looking for, but
But everything in the problem will be negative. Displacement and velocity, yeah. Both.
We can't leave it as like radical if we have.
No, you take the square root, and I'm going to tell you in the test, round to the nearest 10th. Okay, and it says it on the directions. I made sure to put it this year. Last year, I left it blank and people didn't know what to round to. So I'm going to be clear, round to the nearest 10th.
If the velocity and displacement and everything is
Like
Mhm.
if you're going on a straight line south at a negative velocity, then do you really need to differentiate between
You
positive
do.
and negative?
You do, because there's going to be problems in your test where a person starts going south for a while and stops, and then comes back north for a while. And you're going to have to figure out what the idea is with between velocity and speed. So the negative absolutely matters, 100%. Okay? And if you ever hear south or north or east or west, you know that it's either displacement or velocity. It's not distance and speed. Because distance and speed have no indication of direction ever. Okay? That whenever you see north, south, east, west, positive or negative, any of that stuff, think about displacement and velocity. Because those have a direction. Whereas speed and distance are just a number. They don't have any direction.
When you're dealing with like a problem like that, like with initial velocity of negative, you don't, and then like a positive velocity, you just like write, you don't like have to do any special things to find the final one. It's just like positive, whatever they tell you. Like you don't have to like add it with the initial one, because you're going like back the way. it came.
No. The acceleration, the time period, and the duration and the length is taken into account, not adding in the initial already. VI is in the formula. You're technically already taken into account. Okay?
And so if a guy runs south, like 10, like with a velocity of 10, for 10 meters per second,
It would be negative 10 meters per second.
and then but then he runs back up at the same distance with 10 meters, with the same velocity but positive this time.
Okay?
It would be zero. The velocity.
Well, it depends on where he ended and landed. Remember, we talked about this. Velocity, when you're looking, you said average. When you're looking for like an average velocity of a situation, you need to look at their change in displacement over time. If I run across the room and then come back to the same spot, have I really have any displacement?
No.
So my velocity average is zero. But I do have a speed. My speed is whatever the distance traveled, which is the length there, the length back, and together, distance over the time period. Okay? So again, if I travel there 100 meters and back, that's 200 meters in distance. And then I can take that distance divided by my time to get my average speed. But everybody should know that average velocity is just zero because you have no displacement. Okay? Remember the idea of a race car on a track. Every time it loops, when it gets to the finish line, its average velocity again is zero. But it does have a speed because it's going a certain distance. But its displacement is zero. Okay?
So like, shouldn't, you know how like baseball people pitch?
You know how what?
Pitch, like,
Yeah,
shouldn't
a
it be,
pitcher.
shouldn't it be velocity instead of miles per hour?
If it's a straight line motion, it doesn't make a difference. If it's a curveball, it does. So it depends on the motion of the ball. If a ball is thrown as a fastball with no cut or anything on it, it's a straight line fastball, then it makes no difference really. They're the same. But the minute the ball curves a little bit, or tails, or cuts, or anything like that at all,
It has to be speed.
there is a difference technically between speed and velocity.
Alright.
And in the game, they're looking at the speed, not the velocity. They're not saying miles per hour south, or north, or east, or west, or negative, or positive. So it's the speed that a radar gun is measuring. Okay?
So like, if you, for
Guys, these are good questions, because these are the kind of questions for your test that come up in like short answers and multiple choice. So I'm happy to answer these. It's a good thing. I'm glad you're asking.
So for displacement, if you started like right where you're standing and you went around the room and you went like 1 foot away from where you were standing,
My displacement will be 1 foot. My distance traveled to be that whole entire loop plus that 1 foot. Okay?
Speed and velocity have like the same equation.
Average speed and average velocity. The only difference is instead of using displacement, we use distance.
So
Okay.
the velocity is x over t and speed is d over t.
Correct. S equals D over T. Yep.
Oh wait, I know like when we were doing problems, let me just keep me forgetting, but I don't remember using the speed over t.
You might not have used a lot of speed on your... There was definitely a problem, I think, on your problem set where there was a speed involved. Let's do an example then. How about that? Is that good to give you guys an idea of the differentiation between speed and velocity? Test. All right. I'll give you the format. Remind me to give you the format of the test also, so you have an idea of what kind of sections to expect. All right. So let's say that Lisa's traveling from New York, okay, directly down in a straight line in her private plane, just because a plane can fly in a straight line, to DC. Then she travels back, so let's say that's a distance of, oh geez, 5K is 3 miles, 250 is 80, 400 kilometers.
How do you know that?
Just did a 5K conversion. It's about like 250 miles, so about 400 kilometers.
It's not paper computer.
5 kilometers per 3.1 miles. It's like the easy number I remember to convert with. It doesn't matter. You don't have to know how to do it then. So you go down 400 kilometers to DC, and then she comes back up, let's say, and stops here, and this is a distance of 300 kilometers. Okay? And let's say on the way down, it takes her a duration of 2 hours, and on the way back up, it takes only 1 hour to go those 300 kilometers. So clearly, can somebody tell me something about her velocities on the trip? Something about the 2 different velocities. She went down to DC and then back up 300 kilometers. James?
Negative or positive?
Yeah, on the way down it's negative, on the way up it's... Okay, good. We can think of it that way. What else? What else? We're going to think of south as negative and north as positive. Okay?
Yeah.
What else?
Velocity is higher.
On the way what?
Down. Way up.
The way up.
Way up.
Well, be careful. Let's use the word speed here, Lisa, and then it would be correct. Her speed on the way down, she goes 400 kilometers in 2 hours, so she goes 200 kilometers every hour on the way down. Okay? But then on the way up, she's going a distance of 300 kilometers, so it's got to be covering more turf in a smaller amount of time. So let's look at the speed and velocities. Relax with the chair things. On the way down, let's find our velocity. The displacement on the way down is what? What's the displacement on the way down? But you're going south, so it's... Okay, displacement, good. Over a time period of 2 hours. So her velocity on the way down, as we said, is negative 200 kilometers per hour. So far, so good?
I have a question.
Good?
Why are you finding the velocity, not the speed?
Well, I'm going to find both and show you the difference.
Oh,
Okay.
No, we're just doing.
We're going to do a bunch. We're going to do a lot of stuff here. Let's find now the velocity on the way up. Velocity on the way up. What do we got? This should not meant to be tough. On the way up, 300 kilometers.
Divided by 1 hour.
So it's
300. I said 100.
okay. So it's just going to be 300 kilometers per hour. All right. Now, those are the 2 velocities for each leg of the trip. Now, what's her overall velocity from beginning to end? This is different. What is her overall velocity going to be? And please do not say it's the average of these 2 numbers, because it's not. Okay? The overall velocity. Tell me how to find it first. Go ahead.
Alright, so it'd be V equals 7, no, V equals 100, negative 100 over 3.
Can you explain that? You're absolutely right. Explain it.
Okay, so, well, originally, so when you go down, it's negative 400, and then when you go back up, it's positive 300,
So what's this?
100.
Which is where this comes from. Remember, overall velocity for the whole trip is final and initial difference of a negative 100 kilometers. What's the overall time?
3 hours.
Yeah, 2 hours, and another hour is 3 hours. What is this number going to become? Negative what? Negative 33.333 repeating, right? So, it is very obvious right away that the average velocities of each leg and the sum of those and that average is not this, right? Please don't just add these 2 together and say that that's the overall velocity for the whole trip. Now, the place we're going to differ here is to find the overall average speed of the trip. What is the and I'll do that up at the top up here. Okay, so we got, so far, let's see, 1 part, it's 2 parts. Let's do the other part up here at the top. What is the overall average speed of the whole trip? Give me the equations, Julian.
You take the distance traveled, which would be 700 kilometers, over the time, which is 300.
Good. So here's the difference. Again, for the overall velocity for the whole trip, we think of this as a net negative 100 over 3. But as Julian said, we go down 400 meters, up 300 meters. That's a distance of 700 kilometers. Kilometers. Okay? So we're looking for speed here. We take the overall distance. What's 700 over 3 come out to be? 233? 233 and a third? Okay, and that's in kilometers per hour. So take a look. Even though this number is in between these two, it's still not the average of them. Is that clear? Because this is called a weighted average problem. You're only doing a portion of the trip at one speed and a portion at a different speed. So you have to think about the fact that these two, even if you average them, you're not going to get 250 as your overall average speed. Okay? Who can explain why your overall average speed is closer to 200 than it is closer to 300? Take a look at this problem. Because part of the trip you traveled at 200 kilometers an hour, happened to be south right here. Then the other part of the trip you traveled at around 300 kilometers an hour. How come the overall average speed is closer to 200 than it is to 300? Closer to 200 than 300.
Because it's accounting for your speed during which you traveled right here.
Okay?
And this one doesn't, it's only for your displacement.
Okay, that's close. Get a little help. You're right at the beginning. It's counted for your speed in the first leg of the trip. James.
You spend more time traveling at 200 miles per hour than at, what was it?
300.
300 miles.
Perfect, James. The first 2 hours of the trip, here's your average velocity, right? But then the last hour of the trip, this is your average velocity. So you spend more time traveling at 200 than 300. So the overall average speed has got to be closer to 200. And it happens to be a third of the way there because it looks like there are 3 hours total. Look at the significance. 3 hours total. This is a third closer to this one than it is 2/3 from that one. Okay, that's the reasoning for that. Let's go over the format real quick for tomorrow. Yeah.
I don't get why the average velocity, I mean, I get how to get it, but why is the average velocity 33 when the others are in like the hundreds?
Because the average velocity is defined as your change in displacement. What's your overall change in displacement? It's only 100 south. That's all it is.
Gotcha now.
It's 100 down. So no matter what, even though you did all this work, the average velocity, really in the end of the day, you only went 100 kilometers downward. And it took you 3 hours. Okay? Even though realistically you didn't, you know?
And so when you're finding out when we were doing the total average velocity, overall velocity, we were adding up the two distances together and one was negative. Time does not get affected by positive or negative, right?
Time never gets affected by positives or negatives.
Okay.
Nope, never. Good question. Give you a quick heads up. It's going to be 10 multiple choice or 3 points each. There's going to be 4 short answer. I'm writing it on the board, look up. Or 6 points each. Then you're going to have, the last part is going to be a little bit different. Not different, but you're going to have a choice, and I'll explain. You'll have 4 math that you have to complete, and then you choose one of 2 of the last 2. So these math problems, the kinds we're doing now, you'll have 4 of them that I'll write, and you just do them. And then when you get to the last 2, it'll say, choose one of the next 2 problems to do. So I'm taking off one problem simply because it's a B day, and I'm giving you the choice. Instead of just getting rid of the last problem, I'm giving you a choice between the last 2. Tomorrow's 5 minutes shorter. Problem should take you about 5 minutes, mathematic ones. So I'm giving you that choice. And I wrote on the directions, write the word omit on the one you're not doing. O-M-I-T. It means I don't want to do this problem. So I know which one you're omitting. You wouldn't believe how many people do both of them, and then I have to just grade the first one. If you do the first one and the second one, I'm just going to grade the first one. I'm not going to grade them both and give you the better one of the 2. It doesn't work that way. Okay? So write the word omit on the one you don't want to do. At the very end, I usually put some sort of a question, so you have a 3-point question that's not mathematical. It's like a question about the class. So So I might give you a question like about something that we did in lab, but it's not something you can lose points on. It's just a reflection question. Okay?
Is that for every test?
I do it depending on how many points I add up to. So it honestly, this test added up to 97, so I wanted 3 more points, so I put a reflection question at the end. Okay?
So
It also gives me feedback.
these 1 out of 2 questions, if we want to like find the variables for each and then it's the
Sure.
same-
You can do all the work you want, cross off the one you don't want to grade and write omit, but I don't think you're going to have time to do all that. I think by the time you get to those 1 of 2, you're going to be about 5 minutes left, and you're going to want to just look at them and pick 1 or 2 of them.
Alright.
There's similar problems, you'll see. Okay, there's similar problems. They differ in small details. Okay?
I don't know, like, if I can actually like ask you this, but like, where did multiple choice come from? Like, where are they
The
gonna?
multiple choice come from the questions that I asked, like, if I'm traveling to the right with a positive velocity, what would cause me to slow down? Well, a negative acceleration would, opposite way. And you have 4 choices. Or, there would be a lot of multiple choice questions with graphs. So I'll give you, remember the lab you guys worked on? That lab, most of you I think submitted the electronic version, which I hope you did. If you want to look at your answers and go over that again, that's a good way to study. Look at your graphical stuff. All the graphics of position versus time, velocity versus time, that will definitely show up as multiple choice. It'll say, during which of the following time intervals does the object have a positive velocity? And you have to look for the position time, look for the positive slope, you'll see that it's a positive velocity. Or if it's velocity in time, you need to see when the velocity is a positive value. So go over your graphs. Those are the kind of ones you'll see for those. Okay, for the multiple choice.
Is it going to be like you're going to draw the line? So which one of these does it do? Like stay still, then it moves. Like
Yeah,
this,
it depends. I'm not going to tell you, Christian, but it'll be something like that, sure. I'm not telling you what the question is. Other questions? What time after this period? Anybody know the number? Okay. A few more minutes. Those vary. I'll write them on the test. Listen. The math problems, good point, thank you, Nina. The math problems are going to vary in value. So please, if the problem's worth like 3 points and you really don't get it, just skip it for now. Because some of the other ones might be worth 6 points or 5 points. So look at the point value. There's one problem that has parts A, B, C, and D for a math problem. And they're worth 3 points, 3 points, 4 points, 4 points. That's 20 points. No, that's 14 points. Jeez. That's a very valuable problem, worth 14 points, as opposed to the previous one, which is only worth 6 points, because it involves more math. But keep that in mind when you're doing the problems, okay? It has the amount of points next to each one. And traditionally, the amount of points also has a tendency to correspond to the length of the problem it'll take you to do. So if it's worth more, it's going to probably take you longer to do that problem. There's more work involved in that problem. Okay? Tonight, I'm going to put the solutions to the problem sets up. I'll put them up right after this class, actually, because everybody turned it in both classes. So, congrats to everybody. I am very happy with that. Last year, it happened like twice, where people actually all turned it in. That's a really good start, because now you can look at my answers and I have all the explanations. I all write it all out by hand. So I'll put that up under problem sets on Moodle. So you'll see where the problem set was for you. Below that, you'll have the solutions for the first problem set. Is that clear? Yes?
So our problem sets graded.
Problem sets are graded, yeah.
Every question.
Every question is graded worth 1 point. Yep. Every answer you give is worth 1 point. You get a grade out of here. Problem sets go into your homework grade, so you can give a look at your syllabus. If there were 50 answers that you had to give, then it would be worth 50 points. Every problem set is worth 1 point. It's not universal. Okay? The test is 100 points.